Good software is not born from a single moment of genius, but is carefully constructed through the consistent application of simple, time-tested rules. These principles act as a guiding light, helping development teams navigate the complex landscape of building useful and reliable programs. They are the foundation upon which robust, maintainable, elegant systems are built. One of the most foundational principles in building good software is modularity, which is the practice of breaking a large, complex program into smaller, independent pieces or modules. Imagine building a house with large prefabricated blocks instead of mixing concrete on site. Each block, a kitchen module, a bathroom module, a bedroom module. Each module is built and tested independently. Renovate the kitchen later without tearing down the whole house. This is how modularity maps to software. Each piece has a single, well-defined job. They interact through clear, simple connections. That separation makes the system easier to understand, develop, and maintain. Example, an e-commerce site can use separate modules. User authentication product catalog, shopping cart, and checkout. A bug in the cart will not crash the login system. A new developer can improve the catalog without learning the payment gateway. Tip: if one code file grows long and does many things, split it into focused files. Successful projects start with planning before code is written, not a massive rigid document that predicts the future. Planning means define a clear goal and break work into small tasks. Version control is the essential practice of tracking and managing every change made to your codebase. The most common tool for this is Git. Think of it as a detailed history book for your project, where every single modification is recorded as a new entry. If a recent change introduces a serious bug, you can look back through the history and revert to a previous, stable version. It is also the cornerstone of collaboration, allowing multiple developers to work without overwriting each other. It provides a structured way to merge changes into a cohesive whole. Save your code to a remote Git repository like GitHub or GitLab. After a small logical change, you commit with a short, descriptive message explaining what and why. For instance, fix bug where user could not log out. Tip: make small, frequent commits instead of one giant commit. Testing checks that your code behaves exactly as you expect. Writing tests is like creating a safety net. Tests automatically verify functions and features, catching bugs early when they are cheapest to fix. A good test suite gives confidence to refactor or add features. Example: test that add 2, 3 returns 5. If not, the test fails and reveals the issue. Likewise, test a successful login redirects to the dashboard. Tip: add a new test every time you fix a bug to prevent regressions. This practice steadily strengthens your safety net over time. The principle of don't repeat yourself, DRI. It is a fundamental rule for clean, maintainable code. Every piece of logic should have a single, unambiguous representation. In simpler terms, avoid copying and pasting code. Duplicated code means duplicated bugs and duplicated maintenance. Classic example: sales tax calculation. Do not repeat the formula in the cart, invoice, and reports. Instead, create one reusable function. Calculate sales tax. Call it wherever you need the tax. If the tax rate changes, update one place and everything updates. Tip: if you are about to copy-paste, pause. Can you make a shared function? YAGNI warns against building features before they are required. Speculative work often goes unused and adds complexity and risk. Example: focus on write and publish posts, not dark mode you might need later. If many users request it later, add it then. Tip: ask which user needs it and what problem it solves today. KISS: favor simplicity in design and implementation. Simple solutions beat complex, clever ones. A 5-line loop is clearer than a dense one-liner. Tip: if code makes you feel clever, ask if there is a simpler way. Often yes. Choose the simpler path. Code review is a systematic process. One or more developers check another developer's code before it is merged. It is a powerful quality assurance mechanism that goes beyond catching mistakes. A reviewer brings a fresh perspective, often spotting logical errors and potential bugs. They also find edge cases. Reviews share knowledge. The reviewer learns the area. The author learns techniques from feedback. They maintain a consistent coding style. Typical flow: create a pull request, assign reviewers, discuss with inline comments. Examples: suggest clearer names or a more efficient database query. Tip: focus on the big picture first. Do not get bogged down in spacing or commas. Effective communication is the lubricant that keeps the project running smoothly. Misunderstandings, unstated assumptions, and lack of coordination cause wasted effort, duplicated work, and delays. Good communication is not more meetings. It is clear, concise, timely exchanges. Share progress. Raise blockers early. Ensure shared goals and use simple tools like chat or brief daily stand-ups. Example: before changing a widely used utility, send a quick note. Heads up, I'm refactoring the function to support time zones. Let me know if you have any concerns. Practice proactive transparency. After notable changes, write one line explaining what changed and why. Continuous integration means frequently merging changes into a central repo. After each merge, an automated build and automated tests are triggered. Integrate early and often to detect integration errors sooner. Avoid big bang merges. CI makes integration a simple, everyday non-event. Automation acts as a gatekeeper, so new changes do not break existing functionality. Following CI, continuous delivery prepares changes for release. Continuous deployment goes further, automatically pushing changes to live users after tests pass. Common tools include GitHub Actions, GitLab CI, and Jenkins. A push triggers tests. If green, build a package. In CD, deploy to the live server. Changes can reach users within minutes. Tip: begin with the simplest CI. Run all tests on every push to the main branch. This keeps the core code base healthy and tested. Once stable, incrementally add steps like building artifacts and deploying to staging. This pipeline reduces manual effort, lowers deployment risk, and speeds delivery. Documentation is writing clear, concise explanations to accompany your code. What it does, why it is designed that way, and how to use it. Good docs lower the barrier for new teammates and provide a roadmap through an unfamiliar code base. Effective docs are short, example-focused, and kept up to date as code changes. A good README gives a brief description, clear setup instructions, and a few usage examples. Treat documentation like code. Update docs in the same commit. Debugging is methodically finding and fixing bugs. Do not change code randomly. Form a hypothesis and test it. Start simple. Print key variable values to trace the data flow. Example: wrong cart total. Print each item price is added, then the subtotal after each addition to spot anomalies. You may find a null price or an incorrect discount. Tip: add one print immediately before the suspect line and one after. Compare values to isolate the fault. This scientific approach makes debugging faster and more reliable. Great software is not only easy to build, but also easy to change over time. This is maintainability. Most cost and effort happens after launch. Fixing bugs, adding features, adapting to new tech. Design for maintainability. Clear code, good tests, and no hard-coded assumptions. Do not hard-code secrets. Store config in a separate file so updates are easy and secure. Follow the Boy Scout rule. Always leave the code a little cleaner than you found it. Technology changes constantly. Embrace a lifelong learning mindset. Invest small, regular time. For example, 30 minutes every Friday. Read a short article or watch a tutorial on a new tool. You do not need to be an expert overnight. Aim for consistent incremental improvement. Share what you learn. One small tip in your next meeting or team chat. Sharing reinforces your understanding and uplifts the whole team. We have walked through the fundamental rules that underpin good software. Plan with a clear goal and build in small, manageable modules. Use version control and automated testing to create a safety net. Embrace simplicity, dry, YAGNI, and KISS. Lean on collaborative code reviews and open communication. Automate with CI/CD. Write clear documentation and debug scientifically. Design for maintainability and keep learning. To start now. 1. Pick one rule and apply it to your next code. 2. Add one small test. 3. Share a brief note with a teammate. These small actions are the building blocks of great craftsmanship. Start small, be consistent, and make incremental improvements every day. These rules create reliable software and bring more joy to your work. Your journey to becoming a better developer has already begun.